Welcome back, folks. In today's class, I'm going to talk about the new chapter that is forces and fields. And in forces and field, first thing I'll talk about is is the Coulomb's law. So Coulomb's law. So if I write down the formula for the Coulomb's law, it is equal to force of electrostatic attraction is equal to attraction or repulsion, it can be, it is equal to k m1 m2 divided by r square. That is the formula. If you see this formula is closely related to the gravitational formula which you might have learned in the previous physics. So the gravitational formula was g value or force of gravity Fg is equal to g m1 m2 divided by r square. That was the formula we used at that time. So if there were two masses, these two heavy masses, the force of attraction between these two heavy masses is given by this formula Fg equal to g m1 m2 divided by r square, where this capital G is the gravitational constant. Same kind of a formula we will use for the electrostatic force of attraction or repulsion. So if there are two charges, there is a positive charge and there is a negative charge, or maybe there is a positive charge and the other one is also positive charge. So the force which will exist between these two will be the force of attraction. Negative and positive attract each other. Positive and positive repel away from each other. Same goes with the negative charges. So two negative charges, they will repel away from each other, and the magnitude of that force can be calculated by this formula Fe. Fe is equal to K Q1. I shouldn't have used the M1 M2 here, this is my mistake. I should have used the Q1 and Q2. K Q1 Q2 divided by R square. So K Q1 Q2 divided by R square. That is the force of attraction or repulsion between two charges. And then depending upon what kind of a charges, we can figure out the direction of the force, whether it's the attraction or the repulsion. Now, let's try and solve some math problems based on this formula. So I'm gonna take an example. Let's say this is a positive charge given to me, and then there is a negative charge also given to me down here. And the magnitude of the charge is 1.5 times 10 raised to the power negative 6, and the other charge is 2.10 times 10 raised to the power negative 6. These are the two charges given to me. Now, I wanted to find out what is the magnitude of force, and then what is the direction of the force between the two charges. So if we talk about the direction, then direction we can simply say that this is a attractive force between these two towards each other, and then magnitude of force will be calculated by using the formula Fe, which is equal to KQ1 Q2 divided by R square, and k value is 9.00 times 10 raised to the power 9 multiplied by q1, which is equal to 1.5 times 10 raised to the power negative 6 multiplied by 2.10 times 10 raised to the power negative 6 divided by r square. And I haven't given you the distance, so I'll mark the distance also. Let's say the distance between these two charges is 3.30 times 10 raised to the power negative 2 meters, or we can also call it as 3.30 centimeters. Centimeters can be converted into meters to solve the problem. So down here I'll write it 3.30 times 10 raised to the power negative 2 meters, and then I will square this one. So then once I'm going to square this, I will be able to solve these calculations. So after doing the calculations, I'll get the force between these two charges is equal to 26 newtons. Now, uh, the calculation can be sometimes a bit of a problem while solving these kind of a questions. So what you need to do is you need to start with a bracket and then place 9.00 times 10 raised to the power 9 multiply by 1.5 times 10 raised to the power negative 6 multiply by 2.10 times 10 raised to the power negative 6, and close this bracket and then press divide and then start another bracket and then start with 3.30 times 10 raised to power negative 2, and then close this bracket and then square it, and surely you're going to get the answer as 26 Newton. So if you don't know how to do the calculation, apply this process and you will surely be able to get the answer. Now, this is a magnitude of the force. That's why I placed it in the absolute symbol. So if I wanted to find the force Fe, that value will be equal to 26 newtons, and I will write it as towards each other. That's the force value will be. Now, if some of you might find in your formula booklets, it may be written K value is equal to 8.99 times 10 raised to the power 9. So don't confuse it with this. These two are literally the same. There's not much of a difference. They both are one and the same thing. This number and this number. All right. Now, let's look into one more problem based on the formula which we've learned. So, uh, let's say there are two charges. One charge, again, a negative charge, which is equal to 2.10 times 10 raised to power negative 6 coulombs. And charges are always in coulombs. Just when mention the units here. So remember the unit of the charge is coulomb. And then the other charge, which is a positive charge, and then the unit, well, the magnitude of this charge is 1.5 times 10 raised to power negative 6 coulomb, and the unit, as I mentioned, is coulomb. So the distance between these two charges is 3.30 times 10 raised to the power negative 2 meters. That's given to me exactly same as the previous question, but the difference now is I'm going to bring these two charges together. I'm going to bring them close to each other and allow them to touch each other. So negative charge will touch the positive charge. So this negative charge will touch the positive sphere, and then I will move them back to their original position where they were. And this, we don't know what's going on, so both the sphere A and B are moved back to their original position at a distance of 3.30 times 10 raised to power negative 2 meters. Now I wanted to find out the force, how much force of attraction or repulsion is between them. In the previous question, I did not do any such activity. There was a positive charge, there was a negative charge, they are at a certain distance. We were finding the force. Now, what I've done is I brought them closer to each other and then let them exchange the charges on each other and then move them back to their original position. Now I wanted to find what is the force of attraction or repulsion. Hopefully you understood question. Now, how we gonna solve this question? So to solve this kind of a question, we need to follow a simple analogy. So I'm gonna pause the video for a second and let you guys think about it. All right, so hopefully you had a chance to think about it. Now, the analogy which I'm going to follow in this one is I'm going to follow that there are two armies which are fighting against each other. One is a positive army, another is a negative army. The rule of this is that one positive army will clash with the personnel of the negative army. Both will cancel each other, or they both will kill each other. This negative, how many it had? Negative had 2.1 times 10 to the negative 6 personal, and the positive had 1.5 times 10 raised to the power negative 6 personals. So which army will win? Obviously the one which has more onto it. So this one is more compared to this one. So the remaining leftover will be 2.10 times 10 to the negative 6 minus 1.5 times 10 to the negative 6, because this, they all will be killed by these, and this will also severe heavy losses. How much the losses this army will suffer? Same as the number of personals in the other team. So the leftover will be 0.6 times 10 raised to power negative 6 coulomb. And I can mark it as 6.0 times 10 raised to power negative 7 coulomb too. Just I move this decimal to the one to the right and change the exponent here. That's what I tried to do in this case. All right. Now, This is the leftover charge. Now these charges will equally distribute themselves over the two spheres. So these two charges will, as I said, are distributing themselves over these two spheres. So this will be 6.0 times 10 to the negative 7 divided by 2, and 6.0 times 10 to the negative 7 divided by 2. That will come out to be 3.00 times 10 to the negative 7. This is 3.00 times 10 to the negative 7, and both will have the negative charge now. Now, this is a negative charge, other one is also a negative charge, and the distance between these two charges is again same as the previous one, because you moved back to their original position, 10 to the negative 2 meters. Now, I wanted to find out the force between them. So force value will be equal to kq1. Well, let me write down the charge value also, times 10 to the negative 7. 3.0 times 10 to the negative 7. Force value will be kq1 q2 divided by r square. And you're going to plug in the values. 9.00 times 10 raised to the power 9 multiply by 3 times 10 raised to the power negative 7, and 3 times 10 to the negative 7 divided by r square, and r value is 3.30. 3.30 times 10 raised to the power negative 2 and square it. That's going to give you the value as 0.74 Newton. And what this force will be? This will be a force of repulsion. Hopefully you understood these questions. I'll see you with another video. Till then, goodbye.